Okay, thank you. My name is Yi Yang. I come from Innsbruck. I know many people don't know Innsbruck, so let me have a quick introduction to Innsbruck. Innsbruck is a China-based leading total solutions provider for data center, cloud computing, and big data. Innsbruck provides hardware products, including servers, HPC servers, supercomputers, AI platforms, switches, and storage servers. In server market share, Innsbruck is a top one provider in China and the top 3 provider in the world. Innsbruck also provides solutions for enterprise cloud and public cloud and HPC and AI. Innsbruck also provides software products, including enterprise resource planning, human capital management, and big data software. This is my talk today. I will talk about why and how we run OVS-DPDK without Hugepages and in interrupt mode. My original motivation is that it will be very great if we can use OVS-DPDK to handle all the OS use cases and avoid burdensome and boring OS kernel maintenance work. It's not easy to maintain DPDK database and kernel database in the same code base. If we want to implement a new feature and it's kernel related, first we need to apply a kernel patch into a kernel git tree. Then we need to backport many dependent kernel patches to OS git tree. Then we can apply other parts to OS git tree. So this development cycle is very long. Actually, backporting kernel patches is very burdensome and very boring. Especially for a general OS developer, it's more difficult to push kernel patches to kernel git tree because in kernel community, they have different maintainers from OS. They have different coding style requirement. Most importantly, if we can run OVS-DPDK in interrupt mode and you use normal 4K pages, we can save power, save CPU cost, and save memory. So that's why I want to talk this. Here you can see currently OVS-DPDK only can do this way. CPU utilization is 1%, right? It also uses many Hugepages. Hugepage is a big physically contiguous memory. Actually, OVS-DPDK can do this way. Here you can see CPU utilization is low. It doesn't use any Hugepage here. So how can we attain this goal? Actually, DPDK can support interrupt mode. Here is a code piece. Firstly, we can use port configuration to enable interrupt. then we can register interrupt event to DPDK system. Then we can enable interrupt in port and queue. Then we can call DPDK API RT equal wait to wait interrupt event. If there is an interrupt here, interrupt will unblock this API. Then we can call disable API to disable interrupt mode and enter poor mode. Then we can call RX API to receive packets in burst mode. DPDK application also can use normal fork pages. Here we just use --no -huge option to do that. We also can use -m to specify memory size. In order to support interrupt mode and normal fork pages, we need a higher DPDK version, higher OS version, and higher QEMU version. Here I list version number. We must use VFIO PCI and UL driver. We also need to enable VTD in BIOS settings. We also need to enable LMMU by kernel boot parameters. Here is my experiment setup. In this setup, I used DPDK 18.08 and OS 2.10. This OS version only can support DPDK 17.11.3, so I have a patch to support this new DPDK version. This is my setup topology. I will introduce it in my demo later. These are my scripts for this setup. Here you can see I use no huge option to use normal 4K pages. I use VFIO PCI driver. For DPDK vhost user port, I use vdev mode. Here you can see the type is DPDK, not traditional DPDK vhost user. We use DPDK-devargs to specify what PMD driver should be used. Here we use net underline vhost. That is the DPDK PMD driver. It's vhost user driver. The number 0 or 1 is DPDK port number. We also use IFS to specify Unix domain socket path for DPDK vhost user port. Here we start VM with the same Unix domain socket path. By that, we attach the DPDK vhost user port we created just now to this VM. This is my demo. Here I have two hosts. They are physical machines. I connect these two machines by 1 gigabit NIC. In every host, we have two VMs. Every VM has one DPDK vhost user port. Here you can see it's VM1 in host 1. Here IP address is 2. This is VM2 in host 1. IP address is 3. This is the VM. This is host 1. You can see we have a bridge BRINT here. IP address is 71. Here is the OS information. You can see we run OVS-DPDK, not OVS kernel. Here we use DPDK 18.08 and DPDK vHost user port. We also use normal Hugepages. Here is the port information. This is VM1 in host 2. The IP address is 4. This is VM2 in host 2. IP address is 5. This is host 2. We use almost same configuration for host 2 and host 5. Here we also use OVS-DPDK, not OVS kernel. This is the port information. It's same as host 1. Here we check OVS CPU utilization. Here you can see OVS-DPDK PMD thread is there. CPU utilization is about 10%. This is in host 1 OS. You also can see CPU utilization is low. Here we check interrupt event log. You can see currently we don't have interrupt event. If we pin VM2 in host 1, we cannot get interrupt event because currently vHost user driver cannot trigger interrupt event. It's a DPDK vHost user driver issue. If we pin VM1 in host 2, we can see we get some interrupt events. That event is triggered by physical DPDK driver. This is VM2 in host 2. We pin host 2 in VM2 in host 1. We also cannot get interrupt event because for this pin we just use vHost user driver. If we pin VM2 in host 1, we can get an interrupt event, right? It's a physical DPDK interrupt. Here we run iPorf to generate more traffic. Here you can see we can get more interrupt events. If we check OS thread CPU utilization, you can see we get a higher CPU utilization. You can see for OS vSwitch D and PMD thread, the CPU utilization is higher. Here, the bandwidth is not good. Actually, it should be up to 1 gigabit. Why it's low? Because for this traffic, it went through 2 OS instances. OS instances resulted in this low bandwidth. Here, we just stop VM machines in host 2. And stop OS instance. So in host 2, we don't have OS running there. We use RGB driver. Then we run iPorf or this physical port. Here, check connection. It's okay. Here we rerun iPorf or physical port. Here you can see vSwitch D daemon. CPU utilization is very high. It's almost 100%. For PMD thread, it's also be higher. It's also higher. So here we can get almost 1 gigabit bandwidth. So the result is even if we run OVS-DPDK in interrupt mode and use normal 4K pages, we can still get a higher performance. In my setup, actually, I have some no issues. OVS-DPDK PMD thread cannot be blocked. Why? Because in OS implementation, this PMD thread will handle other port receiving. So we cannot wait event. Another API, RT equal wait, will wait 1 millisecond at least. Actually, this is unacceptable. I have 2 possible solutions. One is we can change kernel equal API to support microsecond level timer, but it's a kernel-based work. It's difficult. So I used another way. We use uSleep plus RT equal wait with 0 timeout. It's ugly, but it can work in current OVS-DPDK PM thread. Another issue is DPDK still needs much memory, even if we use 4K pages. I think it's a DPDK code issue. We can improve this. Another issue is we host user driver. It cannot trigger interrupt event. This is a GitHub repo link. I have pushed my OS patch, my command line scripts, and these slides to this repo. You can get them and try it. So I'm done. Thank you. Any question?
All right, let's thank our speaker. And does anybody have questions?
Hello? Oh. Yes, so I have a question about the interrupt mitigation. So in your case, once you enable interrupt, if you have very high packet rate, then do you have something like Linux kernel snappy where you can dynamically switch to the pooling mode? So I guess so that the interrupt processing overhead is lower. That's my first question. And the second question is that you mentioned the vHost user right now doesn't support interrupt mode. So I guess then you have to busy pulling the vHost user device. So isn't that causing the CPU to 100%? But right now you're still showing pretty good low CPU utilization. So I'm just curious how does that done in the case of vHost user?
Sorry, I didn't get your question. The first question, you mean this interrupt mode is similar to kernel part, right?
No, I mean when you receive a lot of interrupt, right? So you have high packet rate, you'll receive a lot of interrupt. So in the case of Linux kernel, it will switch back to the polling mode. So that yes.
Yeah,
so
actually, in my setup, if your traffic is not high, right?
Yes.
It will interrupt mode. If your traffic is high, it will return back to pool mode.
Oh, okay.
So it depends on your traffic workload.
Okay, okay.
For vHost user interrupt, actually it can support interrupt API. You can see I call interrupt APIs to vHost port.
Yes.
It's okay, but it cannot trigger interrupt even. So I think it's a current vHost user driver issue. It's not a technical gap.
And to fix this issue, this is code in DPDK vHost, or it's in the OVS-DPDK vHost code?
It's a DPDK vHost user driver, not kernel vHost driver.
Okay, okay, okay. Thank you.
So at the beginning here, I forgot to introduce our speaker. This is Yi Yang.
Yeah.
And do you have a new job? Have you?
Yeah. In last month, I'm an Intel employee, but in this month, I'm an Inspur employee. Currently, my job is SDN architect. I'm working on Open Daylight and enabling SDN controller in public cloud.
Great. So I'd love to take more questions, but we have to move on to the next talk. I'm sure that you can talk to Yi at one of the breaks if you have more questions. Thank you.
Okay, thank you.
So.